educational webinar. We'll get started in just about 30 seconds. Hello everyone, and welcome again to Corena and Data Conversion Laboratory's educational webinar, Making a Business Case for S1000D, the truth about ROI. Before we get started today, I'd like to explain how you can interact with our presenters during the webinar. Because there are a large number of attendees, we ask that you kindly keep your phone lines on mute and use the question panel in the NetMeeting interface to ask any questions that you may have. During the course of the presentation, we'll also be taking a few polls so that our audience can see what types of challenges other attendees are facing as they consider the adoption of S1000D in their organization. We hope you'll participate in these polls. To do so, when a polling dialog appears, please select the answer that best represents your response. Finally, a recording of this webinar will be made available on Data Conversion Laboratories and Corena's websites shortly after the conclusion of this event. Our first presenter today will be David Skurnik, Vice President of Sales at Data Conversion Laboratory. David is responsible for generating all new business at DCL and for developing client and business partner relationships, as well as ensuring customer satisfaction during data conversion projects. David's been assisting clients with their document conversion services needs for over 10 years, working closely with clients in all facets of publishing, including aerospace, medical, military, legal, and life sciences. David was awarded an MBA from Baruch College at the City University of New York. Our second presenter today will be Haagen Aas, Vice President of Sales for the Corena Group. Haagen is responsible for sales and marketing in the global Corena organization, where he has worked since 1998. Haagen has worked several years for IBM, holds bachelor's degrees in computer science and marketing, and has an MBA from the University of Colorado. My name is Rhonda Wainwright, and as Sales Director for Corena, I'll be moderating today's webinar. We'll strive to answer all the questions that you ask during the webinar, but if there's any questions we're not able to get to today, please send your questions via email to one of the addresses shown above, and we'll get back to you with an answer after the webinar. We'll also show these addresses again at the end of our presentation. Today we're going to talk about the challenges faced by today's technical publications organizations, and then explain how S1000D meets those challenges head-on. We'll describe what's involved and what's required to begin producing S1000D data, and then show how S1000D drives cost savings that will more than pay for the cost of your investments in data conversion and S1000D technology. And finally, we'll share with you some real-world ROI case studies from the defense and energy sectors. Here we'll provide some hard numbers as to the cost savings realized by Corena customers when they adopted S1000D. This webinar is intended to give you a high-level understanding of the factors that drive cost savings and contribute to a return on the investment you make in S1000D. We hope this helps you assess how S1000D will impact your organization's productivity and ongoing production costs. Our agenda for today's webinar begins with a discussion of technical publication cost drivers and a high-level overview of where S1000D promises to make an impact. So I'd now like to hand the webinar over to David Skurnik, who will discuss some of the challenges that drive up costs in today's technical publications organizations. David?
Thank you, Rhonda. The following slide depicts the current realities of the tech pub community. Although all industries are undergoing budget cuts, since Congress is focused on reducing the defense budget, the defense community is under extreme pressure to reduce costs. Also, there is significant pressure in the ATA community to reduce the cost of publication. But although budgets are decreasing, user demands are increasing. Therefore, having to do more with less is a necessity for any tech pubs professional. Now to the slide. To reduce costs, the process and timeline to create new publications and electronic products must be streamlined and condensed. Also, in order to keep pace with the condensed rollout of new systems, rapid creation of new manuals is needed. to comply with more challenging safety standards and to reduce costs by streamlining the pub's maintenance process, management and users alike have been demanding quicker updates to their publications. With the plethora of media and devices used to view technical information, the need to publish in paper in so many different modes of electronic display is mandatory. With more complex missions involving many players, it is well known that a key OSD objective is the achievement of interoperable data. Due to the expense of maintaining multiple specifications and publishing systems, it is prudent to standardize on a single standard and, if possible, even on a single publishing platform. Today's globalization of the workforce, as well as the need to seamlessly communicate with an increased number of partners and customers, requires a standardized data environment. The key to resolving all your aforementioned issues is to implement a single data standard, which was specifically developed to address these challenges.
Thank you, David. While we're on the topic of challenges and cost drivers, I'd like to take a moment to ask our audience a polling question about which process drives the highest costs in your organization. When you see the question appear, please record your answers. Hopefully we'll be able to show the results of the poll here shortly. Okay, interesting. Thanks to those of you who took the poll. I think this is interesting. We can see that 63% of you are actually finding that authoring is your most difficult challenge, followed by data conversion, and then publishing and data interchange. I think that this makes a lot of sense, actually. Authoring is the most difficult thing, and what we'll be talking about you today is how S1000D drives reuse, which is going to really help with that authoring challenge. So again, thank you for sharing this with us, and I hope that was interesting for our attendees as well.
Since S1000D is an XML-based standard, S1000D provides all the benefits of a well-developed XML standard. Now to the slide. One of the biggest benefits of S1000D is the ability to reuse data, as was just stated by Rhonda. S1000D is based on a concept of the data module. The data module is a unique bit of self-contained information. The data module is created in modular format and then published into manuals or IETMs using virtual documents called publication modules. An example of a data module could be a warning to a maintainer or an operator to make sure that the radio in a Jeep is turned off prior to turning on the Jeep. If the radio is on, it might cause a short in the Jeep's electric system. This warning is relevant to anyone who will be turning on the Jeep, and is therefore relevant in many different situations. If one wants to create a new manual or an IETM related to Jeep operations or maintenance, then one doesn't have to recreate this bit of information, since the data module already exists in the data repository. Likewise, if a change needs to be made to this bit of information, the update needs to be made only in a single data module, and not in every place where the data module is referenced. For example, if we need to add to the data module that besides ensuring that the radio is off prior to turning on the Jeep, the user has to also ensure that the GPS is in off position, then the change will be made only one time to the data module, and all the manuals or IETMs containing or referencing the data module will have their information updated. By reducing the time and effort needed to create and maintain manuals and the overall amount of information that needs to be maintained, the cost to create and maintain the information is reduced. The turnaround time needed to make updates is reduced, since there are much less updates to make, and the quality of the pubs increase, not only because updates will be quicker, but also because the pubs will be standardized. Also, by identifying reusable content prior to conversion, the amount of information that needs to be converted is reduced, which obviously reduces the cost of the conversion. We at DCL not only specialize in conversion, but we also have a content reuse identification tool, which was specifically developed to enable organizations to reduce the overall amount of information in their repository and the amount of information that needs to be converted. We have found the average reuse potential to be 50 to 60%. Aside from reducing the conversion cost, what benefits will your organization realize if you can eliminate 50% of your data in your repository? Another benefit of S1000D is its publishing capability. Because S1000D is an XML standard and XML is only concerned with content and not presentation, multiple rendering options can be developed to support publishing to paper and any electronic medium. This includes small screens and handheld devices. Also, the inclusion, order, and prominence of data can be tailored to the user. Information presented to pilots can and should be presented differently to maintainers of an aircraft. Also, different configurations of the system require specific information tailored to that configuration. S1000D enables the capability of user-specific custom publishing. In other words, S1000D enables the capability of custom publishing for almost any situation. A third type of benefit of S1000D is the standardization that it enables. One can more easily integrate standard-based data as well as communicate with other organizations. Since S1000D is SCORM compliant, one can integrate training data with technical data, which reduces the cost of producing the technical data and increases user familiarity with the technical data. Also, with standard-based data, one can standardize the entire publishing platform, thus saving amounts of money while enhancing user productivity and increasing safety. Imagine the maintainer in the middle of a war zone that has to be intimately familiar with several different IETMs supporting his or her weapon systems, or a maintainer at a logistics center that has to be familiar with many more IETMs. Would it be better to just have to deal with one? To summarize, how does S1000D enable tech professionals to satisfy the requirements of today's challenging environment? It enables faster manual creation. It enables the faster manual updates. You end up with more accurate data and less data to maintain. There's an overall reduction in the cost to create and maintain the data. It supports multi-channel publishing and facilitates content reuse across multiple products. S1000D enables standardization, integration, communication, and enhances user familiarity. Now that we have an understanding of the challenges faced by tech pubs organizations today and the promises of S1000D to address many of those challenges, let's talk a bit about business case considerations. In particularly, I'd like to talk for just a moment about new versus legacy programs and how these impact complexity and program cost. If you are a new program and you are in the military or a military OEM, there's a good chance you are mandated to deliver your data in S1000D. If you are given the choice, you should be selecting S1000D since as time goes on, most systems will be S1000-based systems. Therefore, the support in terms of specification development as well as tool support for S1000D systems will be maintained. In the future, that might not be true for other specifications, especially with limited funds available in today's fiscally challenged environment. If your publications are in a non-SGML or XML format, your business case for going to XML will be somewhat more involved because you have to consider the cost of conversion, retooling, QA, and user training. Parenthetically, last week I found out about 2 programs that are a result of switching from a legacy format to an XML-based format. They reduced their costs to produce new manuals and update their legacy manuals by 60%. If you are an existing program already in SGML or an XML format, the business case to go to S1000-based XML is more challenging, since many of the benefits for going S1000D applies to any SGML and XML-based specification. With that said, there's a difference between SGML or XML specifications that are structural-based versus content-based. Structured-based specifications, such as the NAVCC2 or the Air Force 38784, are only capturing the structure of a publication, not its content, thus limiting the types of information that can be gleaned from the data. In contradistinction, the content-based specifications like the Army's 2361 and Navia's 3001 specifications capture content as well. Since S1000D is a content-based specification, the utility of the data will be enhanced when you convert from a 38784 or a NAVCC2 specification to S1000D. Also, the cost to convert from SGML or XML format to S1000D should be lower than converting from a non-SGML or XML environment. So you won't have that real heavy conversion cost if you go from a 38784 or a NAVCC2. Now, what about the 2361 or 3001 to S1000D conversion? 2 of the reasons we spoke about are very relevant. Firstly, the specification and tools supporting 2361 and 3001 might not be maintained and developed as much as the specification and tools supporting S1000D, if at all, especially when the military is being forced to cut budgets. Also, it's costly to maintain multiple environments. So unless you or your customer is only supporting 2361 and 3001, it makes sense to standardize on S1000D. Also, the least expensive conversion is from a 2361 or 3001 environment, since most of the information needed to produce S1000D should be already present. In a nutshell, since S1000D is the future of tech pubs in the military and ATA community, it makes sense to standardize on S1000D, possibly for all systems. Over to you.
Thank you, David. Now I'd like to take a moment to ask our audience another question about where they are in the S1000D adoption process. You'll see a question appear on your screen. Please record your answers just like we did last time, and we'll give you a few seconds before displaying the results. Okay, and now our results are displayed, and it looks like 43% of you have no S1000D requirements today, so you're ahead of the curve. You're investigating, which is a very smart thing to do because these digital data standards are very important, particularly in aerospace and defense. 29% are using S1000D in production today. About 17% in the process of adopting, but not quite in production yet. And then we've got about 6% that are evaluating or have established S1000D requirements, but not the capabilities yet. So I think this is kind of an interesting snapshot of our attendees today, and I think it's interesting to see so many of you looking at S1000D, even though you don't have the requirements today, and I think it's very smart, actually, to be looking forward. Thank you for your participation in the poll today. And now I'd like to hand the webinar back to David again, who is going to talk to us about what is involved with an S1000D implementation. David?
Okay, the data conversion requirement for legacy programs. So we all know that if you're in legacy, you're not in S1000D. So unfortunately, you're going to end up having to go through a legacy data conversion, and hopefully you'll be making the right choice on how to go about doing that legacy conversion. Now you also need to have an XML skill set if you are already not in XML, and you would need an S1000D skill set. Now there's also a significant task is S1000 business rule development. We really don't have time to go into business rules, and that is actually a webinar in itself. You also need technology, like you will need a CSTB, you'll need a IETP, which is commonly referred to as an IETM, and you also need to be able to render possibly render something in PDF or paper. You know, obviously we would all love to get rid of PDF and paper rendering, but sometimes it's in various situations, various environments, you can never get rid of the paper. And also content reuse, it really, although some people don't take the time up front, they may do it at the back, but obviously with the S1000D capability of content reuse, you want to be able to identify as much reusable content as possible, which will enable you to maximize the content reuse benefit of XML. Over to you.
So now we'd like to turn the webinar over to Haagen from Corena, who will talk to us about how S1000D drives cost savings. Haagen?
Yeah, thank you. Thank you very much, Rhonda. Thank you very much, David. I'm going to address some of the cost versus value drivers. If you look at what we have displayed here, is the typical cost challenges are how to handle multiple publications for multiple configurations of systems, of multiple variants of these systems, and of these systems during its life cycle. Also, how to manage multi-channel publishing. Some customers want paper, some want ITPs, some want it on smartphones and other handy devices. And also, how to handle interchange and interoperability of information across multiple organizations in a global environment. Managing these challenges in the right way, for example, by using S1000D, you can create significant value. And this is the essence of this part of the presentation. The value drivers are reduced effort and cost and time to market as a result of automation, new additional revenue coming in from advanced ITPs with parts ordering, being able to charge higher prices as a result of improved quality, and generating significantly more revenue by increasing the availability of the mission-critical systems, assuming there are additional availability to make. Let's first have a look at the traditional way of handling projects, either at a defense logistics organization or at a systems integrator. Typically, a main contractor would get logistics support information from several sub-suppliers who again would get their logistic support information from their sub-suppliers again. This would comprise the total system. But the defense organizations or the systems integrator would have several projects with similar character of this. For example, a helicopter manufacturer may have several programs, but with several common components. For example, coming from the same sub-suppliers. A defense logistics organizations would have several Army programs, also consisting of several common units across systems platforms. In such a traditional setup, there is poor interoperability, it's inefficient, and it is expensive. So now let's see how a standards-based approach would look like. By a standards-based approach, I mean integrated logistics solution based on industry standards such as S1000D for technical documentation, PLCS for product data management, and SCORM for computer-based training. In a standards-based approach, all projects would use same methods and tools, and the interchange between sub-suppliers, main contractor, and customer will be unified and standards-based. Updating and exchange of information would be in accordance with predefined rules. Business rules are defined as how a project shall exchange information and what kind of validation checks that shall be done on the information being transferred between the parties. This would ensure that information being imported into a system integrator's common source database would always be correct. All incorrect and not valid information would be rejected on import and returned to the sub-supplier for correction. Furthermore, the systems integrator or defense logistics organizations would have one common system across all projects. They would have one software infrastructure, the same viewing tool, sharing of competencies, reuse of personnel, and the freedom to choose commercial off-the-shelf IT suppliers and consultants. All of this represents major cost savings and significant quality improvements to both the suppliers and to the customers.
Thank you, Haagen. Now we'd like to ask our audience one last polling question before we proceed. Is or was a return on investment an important factor for your adoption of S1000D? When you see the question appear, please record your answers. And the results should be displayed for you now. Looks like we've got a lot of people who don't quite know yet whether or not a return on investment is going to be something that they need to consider. But it does look like a large amount of you really didn't have a choice. When your customer requires S1000D and you want to continue having that customer, oftentimes you need to just address the needs that they have without looking at the return on investment. However, we do have a good 20% that are in the process now of making a business case for S1000D. And we do hope that this webinar helps you when you make that business case. So hopefully this poll has been interesting for you guys. I'd like to thank you once again for taking it. Thanks. And at this point, you might be thinking, the promise of S1000D is one thing. But what about measurable results from those who have already adopted the specification? Well, as a longtime S1000D vendor, Corena has some really compelling case studies from customers in the energy and defense sectors that Haagen's going to share with you now. So I'm going to turn it back over to Haagen to talk about these ROI factors. Haagen?
Thank you, Rhonda. Let us have now a look at some of the real return on investment cases. The ROI examples that are displayed here are taken from different parts of the logistics support process. However, all examples are related to reuse of XML-based information. The examples include 63% cost reduction by an aero engine manufacturer that increased number of parts catalogs from 81 to 132, and at the same time they reduced the number of authors from 18 to 3. So that's a rather remarkable example. Another example is 20% productivity gain by aircraft mechanics by customizing job cards. For example, an engine removal procedure, which normally takes 100 pages, can be reduced to a 30-page job cards, and it would save 200 mechanics 20%, which is quite a big amount. And if we look into the two next examples, these are going to be explained in more details, so we will have them on the next slides. This is a remarkable good case. This customer is producing integrated defense systems. They deliver thousands of units of remote weapon stations to a multitude of platforms and to a multitude of customers worldwide with several product updates and modifications. The customers see big opportunities increasing their aftermarket business, and the customer did not have any S1000D requirements, but they thought it would be a good idea to do it. They were using Word, they were using structured FrameMaker for years, so hours used for different projects were approximately similar, independent on usage of non-structured Word or structured Frame. That means XML alone did not make much difference for this case. The biggest challenge for them were lack of configuration control, not optimal reuse of information units. And S1000D is normally quite good at that. Although there was no S1000D requirement from their customers, they decided to migrate to S1000D in order to improve configuration control, introduce strong focus on content creation and not spending time with layouts, to reduce information units that are common for several model types. They estimated that S1000D would provide an improvement in the range of 30 to 50% for similar projects in the future. And after only 9 months of usage, this customer was able to demonstrate a 48% cost reduction in hours compared to the average of earlier projects. And this is not all. In addition to the 48% cost savings, the customer has produced 87 technical publications in 3.5 years. That is 2 weeks per technical publication. They start later and they finish on time. They do more with the same personnel. And finally, the revision cycle is reduced from 3 months to 3 days. That's good, isn't it? Now, we have another example. This is a project we've done for Saab in Sweden. The project is called Mantra. It's called Maintenance Training. Saab wanted to improve the efficiency in making computer-based training. Their traditional way was to use PowerPoint and special computer-based training editors. This provided limited reuse, limited configuration control, when there was changes to the aircraft, and Saab therefore embarked on a project to reuse 3D models from CATIA and S1000D data modules. In this project, the 3D models from CATIA are being reduced and converted to 3D XML. Scripts are made to generate a mapping between the 3D XML from CATIA and the XML from the S1000D data modules. And this mapping includes task numbers, task descriptions, hotspotting on the 3Ds, and 3D logic. The mechanic can now perform computer-based training and simulation scenarios in a web-based system, and any changes to the aircraft design is reflected in the CATIA models, and updated CATIA models are mapped again via the 3D XML with the S1000D based work instructions, and the mechanic would get an updated training and simulation environment by minimal effort. In this case, the cost reductions are far more than 20% compared to traditional computer-based training. So another good example. If we look at another important factor that drives the return on investment case here is if we look at the value parameter of availability. What is the value of 1% improved availability of systems? What is the value of 1% more available windmill, or what's the percent of 1% more available nuclear reactors? These are big numbers. Let's have a look at some of the background for this case. This is a case from the energy sector. The energy company has made an assessment of where could correct and efficient technical information contribute to increased availability of energy facilities. Availability is impacted by mean time between failure, which also is known as reliability, mean time to repair, which also is known as maintainability, mean waiting time, which is known as supportability. One major factor influencing the mean time between failure, the maintenance, documentation related to consequences of maintenance are long lead time to find information. These are the 3 bullets in the circle you can see here. High risk in using not updated information and long time to perform maintenance tasks. A factor that includes the mean time between failure is in the next circle in blue, and that's the ability to be repaired. Documentation related consequences are long time to perform maintenance tasks. Next few items impacting the mean waiting time and supportability. That's the long time to purchase right spares, long time to find information, high risk in using not updated information, and high management cost. All of these elements are factors impacting the availability of a mission-critical system, regardless of industry. Now, let's have a look at how we calculate the availability improvements. Here is the result of the formulas or measures that we did in the previous slide. Availability is calculated as a function of mean time between failure, mean waiting time, and mean time to repair. And this formula is in the circle on the right here now, the red circle. Improving the mean time between failure can be done by making less failures. This is indicated by the green colored items in the green oval. Improving the mean waiting time can be done by quicker reaction and more accurate preparation. This is indicated by the red color items and the red oval. Improving mean time to repair can be done by quicker repair and is indicated by the blue colored items. If we look at the table below, we see an example on how many hours that are spent on different tasks in each category today at this customer. This example shows 90% availability. Now let's see on the bottom row the circles that appears here now shows that correct and timely technical information could improve as follows. Finding data and documentation can be improved from 8 hours to 4 hours. Finding spare parts improved from 4 hours to 2 hours. Reworking of work instructions reduced from 2 hours to 1 hour. Rework misunderstood instructions from 2 hours to 1 hour. And control and test reduced from 4 hours to 2 hours. By applying all these new values in the formula for availability, the availability would increase from 90% to 94%. That is 4% increased availability. The two examples below are made by this energy company where 1% availability on average for a nuclear reactor would be 50 million euro per year, whereas for the windmill would be 15,000 euro per windmill per year. Big numbers. And this is all by use of S1000D. Now, if we look at the process of making technical publications based on the S1000D standard, out to the right you will see the end result, which is the paper or the PDF manuals and the ITPs, and even some SCORM-compliant computer-based training for different types of industries. In the middle, you will see the common source database where all the data modules are stored with its effectivity. That is, which data modules are applicable for what configuration of the equipment. The common source database is populated by imported data modules that comes from an LSA database, which is to the left, or via import of transfer packages from a sub-supplier or partner, which you see on the top right, or it's authored by authors at the bottom. Now, let's see where we can identify the cost savings. Our experience is that we can save 20% in the process of transforming LSA data to data modules. We can save 40% for authors using S1000D, and we just showed you a case with 48% savings. We could save 60% for authors on parts catalogs production, and 20% for authors of computer-based training, where we showed you an example with more than 20%. And finally, if we look to the far right, we would have 20% more efficiency for each aircraft or mechanic. Now, let's see how all this adds up. If you look at these savings, we put it into a table. In this case, we have assumed that the hourly rate of a worker is 70 euro, or you can choose $70. We have assumed that we have one person that works with converting LSA data to data modules. We have 20 persons doing authoring of data modules. We have 2 persons writing the IPC. We have 5 authors of job cards, and we have 10 persons making computer-based training. In total, this is 38 people. And if you look out to the right, we have applied how much of a year they are using, and the potential savings for these 38 people is 21,440 hours per year. And this is quite a good number. I would think you would agree to that. If you look further out, you will see how much savings does this represent. In this case, it's 1.5 million euro. Now, in some organizations, you may also have their own mechanics. So in this case, we've added 50 mechanics so that the total workforce is now increased to 88. The potential savings of these 88 persons is 37,440 hours, which represents 2.6 million euro. And how can you now do any justification of such an investment? The savings are quite remarkable. And here's an example where we put it all into a table, which includes the savings potential that we had from the 38 people on the previous slide. That is, we have not included the 50 mechanics in this case. You will see this in the blue circle, and this is after 3 years. You will see that in year 1 we have only taken up 20% effect of those total savings potential. And in year 2 we have calculated 50% of the savings potential, whereas the full potential will be effective in year 3. In this example, we have also assumed that there is an investment of 500,000 euro in licenses and software. There is 20,000 euro in implementing the system, and it is 100,000 euro in annual maintenance. These are put into the red circles, as you can see here. Now, if we look at the net present value of this, that's the blue circle at the bottom, and the internal rate of return. These are very high numbers, and the arrow under the accumulated net present value shows when is the likely payback time of this project, and this is approximately 1.5 years. Now you may think that this is optimistic, but remember our first case, they obtained 48% cost reduction after only 9 months. And we have not yet calculated the value of improved availability, which comes here. This graph again shows the examples we have seen so far where we have a windmill that could improve the availability by 1% and therefore increasing the revenue from the windmill by 15,000 euro per windmill by each year. We also have an example from the oil servicing sector where 1% availability is worth 1.5 million euro per year. And the biggest one is the nuclear reactor, where 1% availability is worth 5 million euro per year. Now, do you know the value of 1% unavailability of your system? If you do you dare to tell us that? Because I can imagine it's rather big. So, to sum up, the S1000D standard has a modular nature with lots of predefined elements, and it can significantly reduce your costs. You may probably have a large amounts of legacy data that you consider to convert as part of your business case. Implementing S1000D will require some initial investments, and this will depend on your current level of expertise. Investments would include S1000D training, business rules development, software technology, and data conversion. It's important to understand where the cost savings and the benefits will come from, and we have shown you some very good examples today. And finally, if you have not made your return on investments calculations yet, we shall be very pleased to assist you in preparing your business case with you. I think that concludes this session, Rhonda.
Yes, that brings us to the end of today's webinar. And thanks again to David Skurnik and Haagen Aas for presenting to our attendees and to our attendees for their participation. If you guys can advance the slide one more, we'll show the email addresses one last time. And if you believe that S1000D is going to be a future requirement for your organization and you're ready to take the next step, we hope you'll consider Corena for S1000D training and technology, and that you'll consider Data Conversion Laboratory for your data conversion needs. As I mentioned at the beginning of the hour, this webinar has been recorded and will be made available for download on DCL's and Corena's websites. We'll now start fielding your questions, so please feel free to post your questions in the NetMeeting interface and we'll do our best to answer everyone. Thank you.